it's a very important topic in operational research. Like simulation is actually mimicking the actual trials and errors that we take in our life. Say in a business environment, if you want to forecast something, you just simulate an environment and just predicts like how the market is, something like that, right? Or you probably preparing an examination, say a competitive exams, you probably try the previous year question paper, right? So you just simulate the environment so that when you appear for the exam, you will not have much problem. And not only that, you will prepare with the existing tools and techniques, online materials, and so on, right? So you simulate the environment so that when you attempt the exam, you'll be flawless and without having much discrepancies, right? So simulation is similarly the same. It is like we'll simulate the environment, right? So this is typically the Monte Carlo simulation, which is a very famous simulation. In fact, being it is water resource modeling or being it production industry, we generally follow Monte Carlo simulation. Let me describe what is that. So an automobile spare parts company or company that sells an automobile spare parts. It's a previous month sale, it's October, something like that, like 31 days. It's listed in the following table. Simulate the demand for the first 15 days of the month. So we're gonna simulate it for first 15 days, fortnight of a month. Also compute the expected demand per day of the spare parts. So this is a very important problem. So a company manufactures the automobile spare parts. Let's take a look at like what will be the strategy in the first 15 days of the company, or basically we need to simulate that environment, right? So this is given number of sales, which is 3. Three parts gets sold in 2 days, and 4 parts get sold in 3 days, and 5 parts get sold in 5 days, and 6 parts in 7 days, and 7 parts in 4 days, and 8 parts in 2 days, and 9 parts in 3 days, and 10 parts in 1 day, and 11 parts in 4 days. So this is given, right? So the total number of sales is the sum of all these things. So 63 spare parts, and if you calculate number of days, it will end up in 31. So this is per month, right? So monthly sale now. So monthly 63 units get sold, and this is the number of days in that particular month is 31, right? Now this is not random variables. Okay, so we will put day 1, day 2, day 3, day 4, day 5, day 6, day 7, day 8, and day 9, and day 10. Right, say so we're gonna have a number of days is given. This is given in the problem, and this is the random number. Like you can probably create your random number when it is not given in the question explicitly, or there are some tools and techniques that you can find random number. Some mathematical formula like midpoint method and all is available. But in Excel, if you ask me, there's a formula you can even write down. Random, it's a random. You it will fetch you the random numbers, or if you want to have a specific random number, then range. In fact, I can have I say 1 to 10. It is random between 1 to 10, so it will give me random number between 1 to 10. Or I want to get random between 1 to 100, and still take it something like 1 to 100. Or sometimes you want to take the random between 0 to some values like 33, randomly chosen value. Still have, or you can have something like here we have got 0 since we had include 0, or some 21 to 33, some random number. still get the random. So this is how you generate the random number. You can randomly generate this. So in the question it is given here. So 10 days. How this sales is something like that. Right. So we need to simulate this particular scenario. Right. I think it is not simulating first 15 days. Is simulating first 10 days. Like you have given a random number till 10, right? So we will be taking this 10-day scenario and we'll be using that particular scenario to find out the how this business is performs, right? The first step is you need to find the probability. So probability, how do you find probability? Is this divided by 31, right? Say the first case is probability is number of days is 2 divided by 31. So that will be, this is the whole value and you can round off this thing. And next is like the second day divided by 31 and so on, right? So if you round off this, probably you can see the nearest decimal places, something like that. You can keep it in 2 decimal places. So that's the interesting thing, right? So that's it. And also perform sum of probabilities. It should always be 1, right? So the sum of probability should be 1. If it is not 1, less than 1 or greater than 1, and there is something like computational error or something like that, we can still adjust the values. Sometimes the error happens because of the rounding off. Since Excel rounds off to perfectly, if you manually round off, there will be some 0.1 variation. So you can accommodate it in some places. Say if it is like less and this is more, you can slightly give the 0.1 to this lesser value so that the entire sum becomes 1 eventually, right? So this is a typical problem. First, we'll lay down 1 to 9. So this is, you just give this row, number of sales. You put number of sales 3, 4, 5, 6, 7, 8, 9, 10, 11. So as given in the problem, it's a serial number. And probability is corresponding probability. What is for 3 is 0.6. For 4, it is 0.10 and so on. Then you find cumulative probability, like 0.06 will be here, and 0.06 plus 0.10 will be 0.16, and 0.16 plus 0.16 is 0.32, and 0.32 plus 23 is 0.55, and so on. And there is a check, right? So as I told you, the sum of probability should be 1. Sum of probability should be 1. And the cumulative probability, the last value of the cumulative probability should be 1. So this is a check, right? So if you don't get 1 and there's an error in the computation, right? So the sum of probability is 1 and cumulative should be 1, right? Next is very much important. It's called random number interval. So let me zoom this and I'll let you know the importance of this random number interval. First, in the first case, we will take 0, 0. We'll take the start point as 0, 0. It's a start interval. Then it is a end interval. So to define this, I'm just giving start interval and end interval. Fine. So this is 0. Since it's the first thing, so we'll start with 0. And the 6, right? So the cumulative probability 0.06. You take the last, or you can take, you can even take this to be next decimal places. So the next decimal place is 0.6. Right. So the next decimal place is 0.6, right? So which means that 0.6 we generally minus by 1. We generally minus by 1. So that is 5. So that's why we have got 0 to 5. I repeat. So we generally put this, or I'll just make it. What we generally do is, given a problem, the first start interval should be 0, and the last interval should be 100. So this is the pattern, right? So you leave out this, irrespective of your intervals. The start interval, the first point is 0, and end interval, the last point is 100. Fine. Then you take this end interval value after decimal places, you minus by 1. Minus by 1. So in the end interval, after the decimal places, 0.06, you take 0.6 minus 1 is 5. Then you put 5 here. Then you put 5 here. Then add 1 to it. Something like, in this case, we'll be adding 1 to here. So I repeat, a little tricky part, but it's really good. So we'll put 0 irrespective of anything. We'll start it with 0. Then in the cumulative probability, we'll take 0.06, right? So 0.06, after decimal place is 0.6. 0.6 minus 1 is 5, right? So that's a value. That value plus 1 will give us 6. So the interval is 6 here. And if you take this thing, the next, the after decimal place is 0.16. So 0.16, which is 16 minus 1, which is equals to 15. So that's how we got here 15. Then we take the same thing, then we'll add 1 to it. That is 15 plus 1 is 16. Then the next decimal, the value after decimal is 32. So it is 32 minus 1, which is 31. Then 31 plus 1, it is 32. Then next decimal, the decimal place value is 55. 55 minus 1 is 54. Then 54 plus 1 is 55. 68, here it is 0.68. So 68 minus 1 is 67. And 67, which is this, plus 1, which is equals to 68. Then equals to 74 minus 1 is 73, and we'll add 73 plus 1 is 74, and 84 minus 1 is 83. Then 83 plus 1 is 84. Then 87 minus 1 is 86. Then 86 plus 1 is 87. So this is how you label this random interval. So 0 to 5, 6 to 15, 16 to 31, 32 to 54, and 55 to 67, and 68 to 73, and 74 to 83, and 84 to 86, and 87 to 100. So I hope you would have understand this particular random number interval. So this has very much importance in simulating the environment. Or I can even show you. So this is what I've done. Or if you wanted to, take this, as I told you, you multiply the cumulative probability by 100, so that you get, in terms of this thing. Then you can add minus 1 to here, and add 1 here in the start and end. So as I replicated here. So since if you are not very comfortable with the decimal places, after decimal places, you can multiply it by this 100, and you have this, so that you can find out the random interval, right? Something like that. So this is another way, right? So once we found out that, next what we're gonna do is we're gonna simulate it for 10 days. So our random number is given here for 10 days. We are simulating it for 10 days, and let's see the simulated value, right? So the serial number 1, 2, 3 till 10 days. So we can even call this to be days. as given, and random number as given in the question. Like this, for 1 day it is 69, 2 days 92, 3 days 31, something like that, right? Right. So this is the random number, and what we need to do is random number 69, like random number 69. Let me hide this for a moment. Yeah, random number 69 falls where 68 to 73. So the random number 69 falls 68 to 73. So the corresponding sales is 8. So we'll put 8 here. And the random number 92. So 92 falls between 87 to 100. So the sales is 11. Then 31. So the random number 31 falls here. Like this is the interval. The end interval is 31. So we'll take this particular thing. Right. So 5. 5. And random number 87. 87 is the initial interval. Here is 87. So it is 11. And we will be filling it for the 10 days. So this is the typical simulations per 10 day. So if I run a company and if I want to see what will be the sales in 10 days, first 10 days, so this is my simulated value, right? So this is how I say in the first day, I sell 8 products. In the second day, I will sell 11 products or something like that. So this is how the simulated values, right? So this is one iteration. I just tell you one. So for the manual calculation, we'll just take iteration 1. So this is the value, right? Then we have total of 71, an average of 7.1. So we will be manufacturing 7.1 items, or approximately 8 items or something like that, or even if we take 7 items, right? But mathematically, in a statistical way, the demand is pi into xi. So we have taken pi, xi is this thing, 1, right? So 1 into 0.06, then 2 into 0.10, and something like that. But if you see that mathematically, it is 0.429 demand per day, something like. But we have simulated, you see, more than most of the it or more than 4, and this is less than 4 or something like that. So that's a demand per day, and this is the sales. You just sell per day or something like that. And remember that this is iteration 1. Monte Carlo simulations are generally taken in terms of multiple orders, like 10,000 simulations, 1 lakh simulations, and so on. So then more number of simulations, the value will almost converge to a more optimal or in a real scenario level or something like that. So that's the advantage of using Monte Carlo simulation. Right. Sometimes in this case, the probability were not given in the problem. We have calculated probability. In example 1, which is this, where the probability is given, and we need to find out the other perspective, right? So this is a very interesting problem. I can quickly explain this. A toy manufacturing company produces 200 toys per day and need to be transported to nearby retail showroom. The daily production varies from 189 to 206. They daily they can produce 189 or 190, 191 until 206. So the minimum value a company produces the toy is 189, and the maximum the toy production is 206 numbers. So that's how it is given, and the associated probabilities are given. So in the previous case, we have not talked about probability in the question, but in this case, probability are given directly, right? And then we need to simulate, the finished products are transported intact, and we need to simulate it for, I think it's 15. Yeah, this is where we will be finding out 15 thing, like 15 days or something like that, right? The finished product has to be transported in truck. So here is another constraint. A truck can only accommodate maximum of 192 toys. Remember, the truck can accommodate 192 only. So if you produce, 192 toys, then there won't be any difference at all, or whatever you produce, this I can even put. Whatever you produce gets sold. I mean transported. Like it's not sold, it's transported in the truck. But if you produce 200 units, then -8. So -8 is not transported. That remains, I mean, the absolute difference is 8. So 8 number of toys remains in the factory. But what happens if you just produce 190? Then 2 toys were missing, were capable, where the truck is capable of holding, but you are emptying the truck with 2 toys. So you would accommodate only 90. The remaining 2 will be vacant in the truck. So that is what the problem is all about. So we need to simulate this environment to accommodate how this things looks. Right. So simulate the following: average number of toys waiting in the factory and average number of empty space in the truck. So this is a simple problem, but do not get confused. This has an additional steps and that's it from there. Right. So what you do is you do serial number. So given the problem production per day, so you copy the entire stuff production per day, and also you can check the sum of probabilities. The sum of probabilities is 1. It should be 1. Otherwise, the problem is wrong. The given problem is wrong. So in this case, luckily the sum of probability is 1, right? And given a random number for 15 days. Yes, yes. 15 days. Yeah, it's 15 days. Right? Something. To show the difference between days and the random. Right. The first thing is the production per day is given. Production in the factory, it ranges from 189 to 206. Right. Then we'll find a probability, which is this given in the problem, 0.04, and run through this. And finally, you'll find cumulative probability. 0.04 is given, 0.04 plus 0.10 is 0.14, and it ranges. And finally, at the last, the cumulative probability should be 1.00. So then it is fine. Next, we will be finding out the random number intervals. So 0.04, so 0.4, start interval is 0, and the end interval is 4 minus 1, that is 3. And 3 plus 1 is 4, that is the next interval. Then 0.14 minus, 14 minus 1 is 13. So that's the next interval, and so on. And finally, you'll have 95 to 100. Right. Now, this is very important. Let me remove this particular. Yeah. Right. So now what we do is we'll take the random number. Random number they have asked for 15 days. So we lay down the random numbers given in the question. 17, 10, 15, 35, and so on. Then production per day. That is from this thing. Production per day. Production per day. Zoom a little bit. So the next step is truck capacity. We know it is 192, right? So random number 17. Random number 17 falls 14 to 25, which is 191. So you type in 191. Random number 10. 10 falls within the region of 4 to 13, which is 190. 190. And it goes on and on. Say 21. Random number 21 falls from 14 to 25. It's 191. And which means we have simulated this particular thing. And normally we will be taking an average production in the previous case. But in this case, we need to find number of toys waiting in the factory and number of empty space in the truck. So you can find either one, or in this case, they have asked for both, the average number of trucks waiting in the factory and average number of trucks in the average empty space in the truck. So we know the truck capacity is 192. If you produce 191 items, so the number of empty space in the truck is 1. So which is you can do it either way, right? So in this case, I'm just looking into the empty space in the truck. So how do I find empty space? Is that I actually take 192, which is the truck capacity, minus the production. Say if it is minus the production, so which means that one truck weights in here, right? Something like that. If I run through it, I'll get this. So 192 minus 190 is 2. So 2 is an empty space, right? Something like that. So this is a typical way that you can find out that the empty space in the truck. So this is a very simple, like 192 is the capacity, we produce 193. So which means that it minus 1 represents the one that is existing in the factory. You cannot accommodate that. So it's an excess than the truck capacity. So that's why it is minus 1, right? So this is number of empty space in the truck. Let's find out the toys, number of toys waiting in the factory. So you can simply do that is, once you find one of the column, you can simply multiply it by minus 1. Right? So simply multiply it by minus 1. So that's how it is. You see, this will become minus 1 and this will become 1. So which means that this is where one of the items is waiting in the factory. Right, something like one of the items is waiting in the factory. As you can see from this, 192 is the capacity. We have produced 193, so one item has to be waiting in the factory. Right, so as simple as that, right? So 0 represents 192 gets produced. So all produced gets transported. So that's why no waiting in the factory, as well as no waiting in the no empty space in the truck as well. So that's something. So this is how you do it. And finally, what you do is you calculate the first that we will be discarding the negative numbers on zeros. So that's why we fill it with this thing. And we fill it with this. And we'll fill it with this and negatives. We generally don't appreciate negative values. And negative values and 0 as well. So if I get to put 0, so I have masked everything. So which means that in this case, one truck, one waiting space in truck for production case, and 2 waiting space in truck and 1 waiting space in truck. And here we produce more than the truck capacity, so 1 in the factory gets it's waiting. And here 1 is waiting in the truck and so on, and 1 waiting in the factory. And something. The total number of items waiting in the factory is 2. So the total number of items, products, toys waiting in the factory is 2. The total number of empty space in the truck is 12. Right? So 12 cases. And the problem given is average number of toys waiting in the factory. So you divide this by the average number. This is 15, right? So 15 days of one items will be waiting. So we can have 0.13. So we round off to nearest decimal places. You can take it as approximately 1. And same way, 12, I think it's 0.80. Same like it is pretty much like 1. So one toy is waiting in a factory, and one toy is waiting. Always have an empty space in track in an average or something like that. So this is typically the simulations. Yeah, come to end of the lecture.